All right, so today we've got a special lecture. We've got a couple of representatives from the UNL Writing Center. And so what we're going to be doing is a team lecture kind of thing where we're going to be talking about writing for design and communication and computer science. We're going to go through several exercises that is going to help you both in writing and in coding and revising code because you draft in both, right? You come up with an initial solution, you refine that solution, you go back and you refactor that solution once it works. And so they've generously agreed to come and show us some techniques for writing that'll help us in our code. And we're going to be talking about your design document, which is due this week. So please go ahead and introduce yourselves.
Yeah, so I am Charlotte Kupsch, and I'm the Assistant Director of the Writing Center over in Andrews Hall.
And I'm Meredith Steck, and I'm the Associate Director of the Writing Center. And so in today's presentation, I just want to give a heads up. It's going to be super interactive. So I've given a lot of these presentations before, and they always work really good when people are shouting out answers. And I'm not ever looking for like one answer or a correct answer. I'm always looking for like a diversity of answers and a diversity of observations. And we're kind of a small group. So I would ask that, yeah, please participate and just say, whatever's in your head at any time. And if you don't feel comfortable, we'll do a lot of like think, pair, share type of things where you'll talk to your neighbor. And you can always tell your neighbor that you want to say something. And we're also going to have paper that will pass out. And if you ever don't feel comfortable speaking, feel free to write down an answer and then hand it to us. And I'll be happy to read it and summarize it for everyone. So there's a bunch of different ways that you can get involved in what we're doing. Okay. So a quick introduction to talking about writing and coding is just sort of a whole a buy-in thing. Like, would that be important for computer scientists who are coding? Well, number one, coding is writing. As we're going to see, one of our goals is to draw parallels between the writing process and the coding process. But the second thing is employers. So what I'm going to show you is data from the National Association of Colleges and Employers. And these folks are an organization, and they collect data from employers as diverse as Apple, Deloitte, American Red Cross, anything. And they sent out this giant survey to them, and about 200 companies responded. And one of the things they asked was like, what are you looking for in candidates when you hire them? Like, what skills, right? And so, as you can see, there's a list of competencies here. And I just want to highlight like the top four. For example, like this 97% of those 200 people who responded said that teamwork and collaboration are essential, right? So professionalism, work ethic is 100%, but again, oral and written communication is up there. So knowing how to talk about your code and describe your code to someone else is, I think, part of this category and going to be a hugely important thing. So one more piece of data is that when these same companies rated, like, when we get a candidate, how good are they actually at doing this skill? You can see that only 40% of people said that their candidates were proficient at written and oral communication. So my view, what I take from this like chart is to say, like, if you are a strong communicator and you can write well and talk about your code well, you really are going to distance yourself and kind of make yourself like really impressive, I think, compared to a lot of candidates. And just like a lot of things, I think writing and communicating and coding all take practice. And the more you kind of engage in it and do it in different ways, I think the more comfortable and versatile a communicator you'll be. So this is just to say, like, employers care.
Yeah, I would add to that every year we have industry advisory boards, industry advisory panels, and they echo these things every year. There are lots of good coders out there, but can they explain their code? Can they work in a team? Can they communicate with a team? Because as you are doing in this class, we're having you team up with somebody, hopefully you choose to do so, on your semester-long project. Now, writing code by yourself, maybe you can do that, but bouncing ideas off of each other, communicating, conflict resolution, all that kind of stuff is super important when you get out into the real world, because No way are your assignments going to be individual from then on. You'll always be working in a team. You will always need to be communicating, whether or not it's face to face with somebody else, or just drafting a well-written email. As far as this class is concerned, good communication starts when you go to a TA and you're having problems. You have a bug of some sort. It's never going to be helpful to either you or the TA or me even to just say it doesn't work, right? No, there needs to be communication there. What have you tried? What do you think the error is? Explain this piece of code to me. Remember, it goes all the way back to rubber duck debugging. That if you try to explain what you're trying to do to somebody else, that forces you to think about it and put it out into thoughts, organize it, and then you can usually come up with the solution yourself. And if there's nobody there to explain it to and communicate to, then you talk to the rubber duck at the top of your computer and explain it to them. And then once oh yeah, that's right, I didn't sort it correctly, or I needed to use a different comparator. That's when the answer comes to you anyway. So practice, even if there's not a person there.
So I used to be a tech writer for a healthcare software company between my bachelor's and my master's. And I spent a lot of time writing about tech, but I really had no idea what was going on. Like, I was an English major in every stereotypical sense of the word, who kind of just walked into this job. And about 75% of my job, 75% of the 50 hours a week I worked was sitting down with either tech support people or developers and being like, okay, man, you got to tell me again how it works, and you have to explain it to me as if I don't know what this code is doing, because I often did not really yet understand how the software worked because I was very new. So this is just another voice to say, this is something that when you're better at doing this, it also helps the people around you who may or may not understand what you're doing. So the better you get at explaining what you're doing in sort of language that's accessible to people outside of your field, the more success you'll have in the workplace, I think.
Cool. So this is kind of what we're going to be doing today. These are kind of 3 different techniques that are really useful during the writing process. So especially these first 2, free writing and also reverse outlining. This one has been like my go-to thing in grad school. My PhD is actually in ecology, evolution, and behavior. So I'm a scientist that got really into learning how scientists write and then how anybody writes in each discipline that gets studied at the university. But this is an amazing tool. So we're going to look at both of these in writing, but also how you can use them in coding. And then lastly, we'll check out how to take a sample of writing that you might be unfamiliar with or that you've never done before, like a design document. How to look at a sample of writing and kind of pick out what are the features in that document that are important for communicating with my reader, that are important to maybe get into my document when I write that for the first time. Cool. So 3 new techniques: free writing, reverse outlining, and then kind of how to analyze a sample of writing that may be new.
Okay. So the first thing we're going to do is do a free write, right? Not being pressure. Okay. Yeah. Free write on the parallels between coding and writing. So free writing might be a term you've heard before, or it might not. It basically just means writing down the thoughts you have as they come to you, kind of continuously. This is not graded. This is not something we're going to collect and monitor you on. So I want to make a quick plug here for free writing just as a practice in general. So again, just writing things down as they come to you, kind of just doing a brain dump on the page. This can be a really useful thing outside of when teachers are making you do it too. It can be a useful thing in any kind of composing process, whether it's code or whether it's writing in a more academic prose situation, because a lot of times we get hung up on the form something has to take. If I'm writing an essay, I might think about, well, I know the introduction has to have a hook, and then suddenly I'm sitting there for 20 minutes trying to think of a great hook and not thinking about, okay, what is actually the information I need to get out. So free writing is a great thing to do if you're stuck or you don't know where to start. It's sort of just getting all your ideas out. So I think you read for today this piece, writing good code is like writing a novel. So the author posits that the process of writing code and the process of writing a novel are similar. And in one section, the author really specifically focuses on drafts. So in the next 10-ish minutes or so, I want you to think about how you draft an essay or any kind of piece of writing. So what are the steps you take to get from an idea to a final draft? So how do you get started? How do you translate your ideas onto that page? And then think about how are these steps that you would take to write an academic paper close to or similar to your coding process. So take some time, think about that.
So I'm going to time you for 4 minutes. So this is just writing whatever comes into your head. If you can't think of anything, write like, I can't think of what to write. I can't think of what to write. That is an acceptable answer to this prompt. But
2 minutes and then 2 minutes.
The point is just, I'll tell you when 2 minutes are up to encourage you to switch to the next prompt. On your marks, get set, go. Okay, if you haven't switched to that second one yet, go ahead and start writing about how these SIPs are maybe similar to your coding process, or perhaps not similar. Just how do they compare? All right. So I'm curious, especially about that second question. So, what are some parallels you all see of like writing?
I said that an outline for an essay is similar to pseudocode, so that you're just trying to just outline where you want your essay to go or where you want the code.
Cool. So like pseudocode.
It's like code without actually using any languages. So you just outline what your process will be.
Cool.
I think one thing that's important for me in both writing and coding is just like the rough draft, I guess, like just getting it written the first time through,
Mm-hmm.
so that I can come back to it later. But that's the hard part for me because sometimes I like plan ahead too much, so I have to just get it done and then come back to it.
Yeah, but it sounds like when you write that first draft, you write it knowing you're going to write a second one. That is, I think, the key. Is like knowing, like, accept, like, it took me so many years to realize that, like, I have to do 3 drafts of a thing for it to be, like, decent. But, like, admitting that in some ways frees you to write that there's an essay called Shitty First Drafts.
Yeah.
Actually, like, yeah. But I think that totally applies to coding, too. Like, get that shitty first draft out of the way.
And I mean, that's how you deal with writer's block. That's how you deal with the, I don't know if you've had it before, but I don't know where to get started syndrome, right? I don't know how to get started syndrome, right? You just free write, right? I'm going to have to open up a file. I'm going to have to process each line by line. I'm going to have to process a string. So you've got all these things, and then you can reorganize them later on. And from a programmer perspective, what do? You know, you can use a commented section outline with a bunch of to-dos, right? Gee, it'd be nice if I had a function to do this thing. I'll worry about that later. I'll put a to-do here and just assume that I have that function, and I'll write it later, right?
I actually did, when I coded for my PhD, I did it in R, and it was, you know, very minimal compared to, I'm sure, what you all are doing now. But I would kind of take out a piece of paper, and before I knew I wanted to accomplish, like, a thing with my data, I would just, like, take out a piece of paper and write down all the things I knew needed to happen. Like, I know the columns need to be made into rows, and I know this, and I know this, and I would just kind of, like, get it all out in, like, a 10-minute craze, and then I would, like, sort through them and be like, okay, which are the things that are essential, which should go first, like, and doing that little bit, that, like, freed me up a little bit, whereas when I would go to write the code, I'd be like, I don't know, what do I call up first?
And when you do that in a collaborative environment with more than one person, you know, paper doesn't work anymore. What do? Whiteboard. That's whiteboarding, right? Bouncing ideas off of each other, drafting up here.
Did you have your
Well,
hand up
I
before?
mean, it kind of just goes off of the rough drafting, the processes, the writing process and the coding process have their own form of like editing, writing, and debugging and code. Those are usually going to be very heavy, just working out all the errors or things.
How do you debug a code?
Well, you first have to know what is going wrong
How do you figure that out?
by usually running test cases.
Test cases. Cool.
Or just testing, or just trying to compile the code and see if it is syntactically correct.
Do y'all ever run test cases with your writing?
How would you do that?
We would have other people read it.
Yeah.
Yeah.
Yeah. Sometimes I read it aloud to myself with, like, you know, a job application, like a high stakes document. I don't send anything out. Or like an email that's like to a person I'm really careful with my language. Like, I'll always read it out loud because if I don't have another person's ideal, right? Because they're not inside your head, so they can like really process what you've written. But like,
So when you like tackle like a topic or like a problem, like split it into subsections and then think about the specific subsections of those problems and how you can tackle those specifically first.
Yeah.
Also, like when you're writing, like once you're done, you're like, oh, this looks good. Then you go back and like kind of break up the paragraphs and shorten things. So I feel like code, you kind of like after everything is running and it's perfect, you don't like be like, okay, it works. You kind of go back and like make sure that it looks pretty and other people can understand it.
Totally.
What do we call that? So revising, editing over, and writing. What do we call that in code? Refactoring. What was it? What was your word? A trim pad.
Well, it was interesting. I was asking in the other class, like, what is the audience for code? Right? Like, who is the code destined for? Right. So, like, the computer, someone else, though, who might have to change it, and maybe, like, your future self, right? Who's going to come back and, like, want to do the same thing. And, like, making it look pretty and kind of curating it so that those audiences will look at it and be like, oh, I get it. Is really important.
Remember, that's where documentation comes in too. Documentation is written for other people. Code is written for machines and other people. Code should be self-documented. That's why you use good variable names, good function names, good style guides, etc. Yeah.
I was just going to say, occasionally when like you have a function that does like a really complex thing, like a byte of code that does a really hard to understand thing, you put like a lot of documentation there, and it's kind of like an author's note. It's like this might not make sense immediately, but here's the thought process behind it, and here's how it works and why it works.
So personal explanations, which is something, if you've taken a first-year writing class, you may have been asked to write an author's note to explain what was going on in your head as you were writing. The same thing is if you ask like your roommate or somebody to read a high-stakes piece of write, like a cover letter for a job, and you're like, wait, first you have to know, like, I know that there's issues here, I know that I have questions there. It's the same thing, right? So one of the other ways in which coding and academic or regular writing, I guess, are the same or similar is that we can use reverse outlines to understand both. So a reverse outline is basically like an outline, except you write it after you've already finished working on whatever piece of writing you're doing. So a regular outline, it's sort of a roadmap. A reverse outline is sort of like the Google map data about where you've been, right? So it's going back in and identifying the main things that you've done in this piece. So in writing, what we do is we start with a complete draft. You wait until you've finished writing that shitty rough draft. And then you go through and you go and look at each paragraph and you think, okay, what's the function of this paragraph? Not necessarily what are all the main points it's making, but what am I trying to do with this paragraph? And you write a sentence, here's what this paragraph is trying to do. More complex paragraphs, you might have some subpoints there. And then you number your paragraphs. So this can be really useful when you have a draft that's finished and there's something that's not working and you're not sure what it is. It can be very useful when you're having issues with your organization or something doesn't make sense. It can also be useful when you're like, man, I had to write this at 2 in the morning and I just brain dumped on the page and brought it to class. And now I need to figure out what the heck it is that I just said, right? So it's a different way to look at your writing and figure out what's going on.
So here's like an example of what a reverse outline would maybe look like. So we're going to say like this is a cover letter. Okay, so we're going to reverse outline. This is the beginning of a cover letter. So if I were going to reverse outline this cover letter, I would kind of break it up into kind of meaningful chunks or often paragraphs. And then we're going to summarize the function of each paragraph. So in this one, I'm saying I am writing with great enthusiasm to apply for this job, and I am currently this. And then, if I were to summarize the function of that paragraph, what's not important is like who I actually am. Really, what this is communicating to a reader, it's like introducing yourself, right? And your purpose for writing. That's what I would say like the function of that paragraph is. So for this second one, I have 7+ years of experience, and I'm currently responsible for doing X, Y, and Z. What would you say like the function of this one would be? Just go ahead and shout it out.
Provide your qualifications.
Qualifications, yeah. Like, why am I qualified to do this job? Exactly. And the purpose, it is kind of tricky to train yourself to think about function, right? Because you're so used to summarizing content. But it's like a little bit different, right? The function of something. So yeah, I'd say like this second one is explaining why I'm qualified for the job. And you could imagine that if I wrote a first draft of a cover letter and I had like 7 of these paragraphs and I kind of wrote down the function next to each of them, maybe I have 3 paragraphs that are qualifications. And I'm like, that's kind of overwhelming. You know, you do want to talk a fair amount about your qualifications, but you could say like, wow, the function is really kind of like doing, all these 3 paragraphs are doing the exact same thing. Can I, break them up to be my qualifications for leadership and my qualifications for something else? Like, are there different ways that I can maybe make this sound a little less repetitive? But you can also do this with code. And I think like after a first draft of your code, making a reverse outline might actually help you figure out a lot of these same flow issues. So let's try reverse outlining some code.
So unfortunately, this is a little bit cut off over here, but this is an exercise that I've given before. It's a suffix array. Given a string, you want to compute all the suffixes and then sort them and report that as your output. This is used in DNA and some bioinformatics algorithms and stuff like that. So for example, science, just one string here, the suffixes are, well, first of all, the string itself is a suffix. But then you just chop off the first letter, and that's the second suffix. Chop off the next letter, and then that's the next suffix, right? It's the appended, the end, the suffix of each string. Once you've got all those, then you sort them in lexicographic order. So obviously the C's would come first, then the E's, et cetera, all the way out down to the other one. So this is just a quick, this is a very simple exercise of, string processing, loops, searching and sorting, etc. So let's take a look at the first solution.
So this is the code that I hope you would know better than me is doing the thing that it's supposed to be doing here. So what we want you to do is take a few minutes and try to think through, maybe talk with somebody or think for a little bit and then pair up, talk to somebody around you, and then we'll ask you for what you've come up with about how you would go about reverse outlining the code. So think about what the function of each of these sections of code is. What is it supposed to do? So take a couple minutes and work on that.
Talk to the person next to you. Or if there are three of you, then talk.
So, the first one obviously is reading the book of science. It looks like it's grabbing.
Sorting.
I feel like yeah, so that's a job. Dot substring will take from I and I want to. Yeah, so like for the first one, it would just be a number, and the second one it would be. Yeah. Yeah. It's if you like don't use the string builder class.
Okay, so as you wind up those discussions, what have you come up with? How would we start off the reverse outline for this code? What's the first section of code doing?
We said the first section was taking whatever word was put in and splitting it up into the like the suffixes and putting it in an array to like hold it all and like store it. So it was just basically splitting up the word.
Okay, all right, splitting up the word. What is happening next?
Oh, sorry. I thought you went one by one.
No.
I'm cheating.
What's happening next?
How did array list? Hopefully, I heard. How do you know that? That's what it says on the box, right? So one thing that I've observed from the reverse outlining is that if you on your reverse outline, if you basically have a word for word copy, then that's like perfect code over there, right? One liner, just crystallized down to just one idea. And if you've got one idea over here and it's just one line of code over there, that's like the perfect outline. Because it doesn't get any smaller than that.
And this is true in writing too. Often you'll find that if you've written really clear topic sentences to your paragraphs, the function of the paragraph is like what you just said it was.
Before we go on to the next one, how did you also, what other indicators did you have here that there are probably three main parts to this? Spaces, good style, right?
Yeah, the formatting super important.
Formatting, everything is aligned, right? You don't have just double spacing for the sake of double spacing everything, right? You have logical chunks together. That's why we call them chunks.
Cool. Okay, let's do one more example.
Is there a way to disable the camera really quick? There we go. Oh
So
no.
create a reverse outline for this.
Sorry. I don't know how we're gonna get that back now though. Sorry.
Giving away all our punchlines.
There we go. Okay, I got it back. Dang it. They're not even going to see the last line anyway. It's going to get cut off. That's good because if it can't contain it, then
Yeah.
Right. I'm really so the no, it's temporary. Yes, I agree. Yes. And then for one, but then they're actually stuff empty. Yeah,
I'll rewrite the times.
Oh,
It's
yeah.
just two. Yeah.
come on. There. Now it's restarting.
Okay, so why is this harder?
Okay, but say more. I heard useless stuff.
So they left
What's
in
useless?
commented out code that doesn't have any purpose anymore, and it's not like meaning anything. It's just code they didn't want anymore, but they left it in.
They left it in so that the / marks at the beginning are.
If you go back and revise an essay, do you leave all the sentences that you deleted in there? Which is crossed out lines? No.
And the notes to yourself about what you're going to say or what you're going to find.
A lot of redundancy. A lot of stuff that does the same thing. It almost seems to like undo itself at some point.
Anything else that's making this especially challenging?
No documentation.
Go for it.
That format just sucks. Like, it's like concurrent with each other. Like all like the sections are like even the bottom part is like there's like two sections just thrown together, and it's not very well separated at all.
Variable name.
Yeah.
Temp2? No. What is this doing right here? Min index and then does a swap. That looks like. That's sorting it. It's selection sort, right?
No.
So, the first sin here is, do you do this? Do you roll your own sorting algorithm? No. The second, even worse sin is that they've got the terrible sorting algorithm here, selection sort, right? The third is there's no documentation here to tell you this is what you're doing. Right? So don't reinvent the wheel. Right? And even if you did have to reinvent the wheel, even if you did have to do something like this, what is this screaming to you? Say that you lived in a world with no sorting algorithms and you had to do this. Where do you put it? You document it, yeah.
Put that in a separate function.
Put it in a function so that it looks like the first draft where there was collections.sort, like mystuff.sort, wherever you're putting that algorithm.
Yeah, and the hope is that like maybe your first draft does look like this, right? Like maybe this is what comes out when you're just like, I'm gonna try it. But the important bit is if you reverse outline and try and like it sometimes when I'm like looking at revising a piece of writing, I don't know where to start in revising, but if I start by making a reverse outline, you usually start to see patterns in your writing kind of that come out, that where you can combine paragraphs, or maybe two paragraphs are saying the same thing, or maybe you have two things about a topic that are in vastly different parts of the essay, and you're thinking like, oh, this paragraph could join this one really well. Like those sorts of ideas, I think, are really helpful. And I use this on any piece of writing, whether I'm writing a scientific article for behavioral ecology, or a close reading of a poem. I think this reverse outlining technique can really, really, really help.
I also, that was something that I should have added this morning, is that you do this all the time in software development. It's called a code review. You wrote some code, and before you check it into the repository and it gets pushed to the main branch or whatever, you might have to have at least another pair of eyes on it. So you have to sit there and you have to explain to somebody else, this is the code I wrote to solve this ticket problem or whatever. And it's their opportunity to critique the code and say, this is not acceptable. We're not merging this in the master, right? Or it's their, they can be more constructive with their criticisms and say, oh well, you know what? We have a function to do that. It's not a standard function, but you can go ahead and use it. Oh, okay, great. That's I'll go ahead and incorporate that. That goes back to, I forget who said it, but you give your drafts to somebody else and get a second pair of eyes on it. Right, and that's part of the writing process, the revising process.
Cool.
Code reviews. You'll be doing a lot of them.
Okay, so we're going to shift gears a little bit now and talk about design documents, which is what you're working on in part in this class. So the three of the questions that I always tell students in my writing courses is to think about, okay, what are you writing? What is the purpose of what you're doing? And then who's it for? So who's your audience and what's your purpose? So some of the same strategies, again, that we apply like in writing classrooms, we're going to apply here. So who knows what a design document is and who it's for? Go for it.
It's kind of a big overview of the project, and it's like for the engineers who are going to be working on it, and like your boss, and then like people who are like interested in it can also read it, but like mainly it's for the people like you are working on, like your clients and like every member of your team.
So all engineers, those people, or not all engineers?
Not all.
Not engineers. So engineers plus some people who are interested in using the code.
Yeah, and people who might have high stakes in the project, but maybe low accessibility to that kind of knowledge, right? So this question, who is it for? You always want to think about who's my audience, and then also what do they already know and what do I need to explain to them? It goes both ways, right? Because you don't, if you're writing only for people in this class, you don't want to over-explain, right? You don't want to be that guy. But most of the time, the greater error is when you don't explain enough and then suddenly somebody doesn't understand what you're talking about, or they misunderstand what you're talking about. So why are these documents important? Why is a design document something important to do and important to do well?
Kind of so that like everybody's on the same page and everyone's clear on what they should be doing and how they're doing it, so that there's not any like confusion and like butting heads.
Mm-hmm. Absolutely. So everything is clear and everybody knows where you're going. Yeah.
In case something happens, you have a base idea to fall back on.
A base idea to fall back on, and also some documentation for what you said, and it's a way to tell people, okay, this is what we agreed on. We all knew the information was here, right? Other reasons, yeah.
If your design is bad, you'll know about it before you start.
Right, because it'll come out in your design document, right? Yeah, absolutely.
If it sounds bad in English, it's going to be bad in coding.
Mm-hmm. Yeah. Anything else about design documents?
Why do I have you write a design document? Oh, let's do a week before the actual code is due. Yeah.
So that we like think long term about the project and don't just attack it in small isolated bites.
Exactly. So you're not waiting to the last second to get started, right? No, I can't stop you from only starting to write code at the last second, but at least by going through a draft a week beforehand, then you're at least thinking about the overall design. And also remember that there's always a bake-in period. You might write a first draft of your design document, and then 2 days later, after thinking about it in the back of your mind a little bit, well, you know what? That's like you said, it turns out to be a bad design on paper first. So you go back and you revise it, right? And it gives you a mechanism like whiteboarding. It gives you a mechanism to think about that first design first. Because remember, there's another thing called technical debt. And it can be summarized with either you do it right the first time or you find time to do it over. So by investing a little bit up front with thinking about the design and writing a design document, it'll pay you interest later on in saved time. Whereas if you just start writing and go down the wrong path, right, you're taking out a loan on your time because in the future you'll have to find time to redo it, redesign it, and re-implement it yet again.
Someone also said like their boss would be a potential like audience for like this kind of a document, and maybe if like your boss was envisioning some kind of plan or some kind of function that this code would serve, and you get the design document, and your boss reads it and is like, oh no, I didn't want the code to do that. Like, that saves you from having like written the entire thing in a lot of ways, or maybe you have written it by the time you provide a design document.
Well, if you want to break it down even further, that would be the elicitation phase, and then you'd have a different document.
Then you have a
called
different
the
document for
requirements
that.
document, that we're not really doing because I give you the requirements.
But it does sound like it gives someone the opportunity, like your client, to give feedback on the code, because if you handed them code, they're not going to be able to read that. So I think the better you describe what your code is doing, the more closely it'll match like what your client's goals are.
A requirements document is also a CYA mechanism. So a requirements document is you have all these requirements, and if they sign off on it, that's like a proof, a galley proof or something. That it doesn't matter if there's a typo or something like that. You agreed to it. This is what we're doing, right? And then if they come back and no, that's not what we meant, you can say, okay, well, we can fix that for you, but we're going to renegotiate the contract or something. CYA is cover your ass. So it's a CYA mechanism, but having a requirements document protects you basically. So having a design document does that too.
So, okay, for the purposes of this class and also in your life and classes beyond this one, what do you do if you don't know what a design document is or you have no idea how to write one? What would you do in this class?
Look at samples.
Sure, okay, yeah. Where else could you find, or where could you find those samples, or where else could you find more information about what you're going to do for this class?
Talk to a TA or the professor.
Mm-hmm. Where else would you go?
Where am I going to tell you to go? There you go.
Yeah. So first, if you wanted to, just think about what the instructor is looking for before asking the instructor, you could explore Canvas to see if Canvas is holding any answers to your questions. And if you click on Overview and Requirements, there's kind of a nice summary of a little bit of what a design document is. The design document should be clear and comprehensive enough that a reasonably technical, competent person could reproduce your system design, though not necessarily every detail, with identical functionality without access to your actual code base. So again, a lot of those answers to the questions on the top are there. And then how you will be evaluated. And so what I'm taking from this is, again, like we said, the audience is actually pretty broad. So not someone who's necessarily familiar with the actual code you wrote. And also I'm thinking clear and comprehensive. Those are the other words that kind of jump out to me. And then we heard about samples. So if you look down here under the camera display, there are some samples. And so the next thing we're going to do is kind of take one of those samples and go through and kind of analyze how you might take, why is this particular sample doing an effective job at being a design document? How is it clearly and comprehensively communicating kind of the purpose of your overall project? Okay, so we've discussed reverse outlines. Now, one thing I do when I want to learn a completely new piece of writing that I have never learned before, like say I had never written a cover letter, right? And I obtained a sample of a cover letter. I was like, what even goes in a cover letter? What order? What do I do? I got some sample cover letters, and then I went and I reverse outlined them. So I mentioned kind of the goals of each of the sections, right? So take a second with a partner and do that for this document. What are the sections and what are the goals of each section? This one is just a zoom in. Mm-hmm. Also explains why. And then I would go out more. How it is like the elements of this. Yeah. So there's like yeah.
Okay, so what's the first thing that you put or that you would put on your reverse outline for this design document? Or like what's happening first in this document? What's the function? Describing the process.
Yeah, that first section, describing the process. How did you know that that was like what it was?
Just like how it says like multiple phases and then it lists out this phase, this phase, this phase, like what's it gonna do?
Yeah, it's pretty simple, right? Like the title is literally approach, and then there's 4 phases, and then 4 bullet points for the 4 phases.
What is going on next? What's the function of this section here?
It's like the goals or like the uses of the project, and then like down the bottom it says like the guidelines that will need to be followed, like what you have to pay attention to as you make it.
Mm-hmm. Yeah, so going over goals, and then again breaking it out into bullet points for the uses for it, and then putting in best practices down at the bottom. Yeah, so this is pretty straightforward, right? This document sort of tells you the reverse outline as you go. Kind of like how when we were looking at the code that wasn't scary, it seemed pretty self-evident, right? It does what it says, right?
And I think like it's super important to point out like not all documents are like this. Like in a lot of different kinds of writing, you're not as upfront and obvious, right? Like this looks like an outline kind of fleshed out a little bit more. Like it's real easy to see like I'm going to describe the goal of the first section is to describe your approach. Why? Because it's titled approach. Like that is obvious and kind of funny, but it is also valuable. A valuable element, I think, of design documents is navigability, right? Like being able to think of really clear titles that really set the reader up to anticipate like what kinds of stuff is going to happen in that section.
What other things, just sort of visually looking at the way it's laid out, what other sorts of elements do you notice in this design document? What, if you were trying to sort of emulate this genre, what kinds of things would you pay attention to?
Like formatting.
Mm-hmm.
Like they have the 2.1,
Mm-hmm. Yeah, so everything is laid out in numbers. It's a pretty straightforward system that makes sense. I think, yeah, there's not more than 2 sentences of like straight text before you break it out into bullet points, right? Other things that you notice about the structure or the way it's laid out. What about, I mean, so in a minute we're going to zoom in on a particular section of this.
Yeah, we'll just do right
yeah,
here. So
we'll do
this
that.
is, let's take a closer look at some of the language here. What about this language makes it easy to read? And I'm thinking words and sentence level stuff.
Everything is stated with a lot of like intentionality to make sure that people understand exactly what's being talked about. It's like the first thing is like during the requirements phase, the initial version of this document is created, and it just basically, like the entire approach section describes the life cycle of the, not even the project, but just the document, and it makes sure that in the language, anybody reading it can understand what each of those phase terms means.
Mm-hmm. Yeah, other stuff. Oh no, you were just like,
They're all like syntactically similar, so like they start each sentence with train the whatever phase. It's kind of like encoding. You
Yeah.
can have your entire program be like similar to syntax.
totally. We call that parallel structure. That's like a really effective thing if you're comparing two things, structuring the 2 sentences of the things you're comparing so that they both flow the same way. Like during blank, we do this. Like that's super effective, especially if you want the reader to approach each phase the same way.
They also like flow each bullet point into the next one. Like they mentioned, like in the department's phase, they mentioned system design phase right before they switch.
Yep. Totally, totally. There's a lot of, even within these, among these 4 bullet points, there's connections.
Avoids heavy use of like jargon within the field unless it's necessary.
Could you go back one slide too?
Yeah.
What else? What other jargon do you see here? What the hell is TANF? What is J2EE? I don't know, but we've shortened them up and used the acronyms. If I had if I was in that area, I might know what TANF is, but I'm not in that area. So this is kind of something that is a counterexample to writing versus code. We don't like short, terse, non-descriptive variable names that are acronyms or something like this in general. But in writing, we like that because we don't have to write it out every single time, 4 words for the same thing. Where would you find what TANF is in a document like this? Yeah. Glossary, and along with the glossary is going to be an abbreviation list. So there's abbreviation, there's abbreviations, there's acronyms, there's glossaries, there's indices, etc. Right? Sometimes it's in the formatter, sometimes it's in the aftermatter. Where it belongs, that's the IEEE standard, and that's the those are the templates that we give you, so that you don't have to worry about that.
The other thing about language like this that uses that parallel structure, it's sort of teaching your audience how to read it, right? So as they go through and they see this parallel structure here, that's what they're expecting down here. So just another reason you don't want to change it up on them at the last minute, because you're teaching them what to expect from your document. The other thing that you should always keep in mind is that people do not like to read these documents. While they can, as a writing PhD student, I think that writing like this can also be very beautiful and very elegantly done, and can look really nice and make me really happy. But most people do not enjoy, like, you're not reading this for fun, right? So you want to make sure that people have the information they need and it's as clear as possible, and they don't have to wade through a bunch of verbosity to get to it, right? People do not like to read this kind of document. So you make it as smooth and easy as possible for them to go through. And that's a good thing to keep in your mind as you're working on this kind of stuff.
That's the fundamental difference with technical writing versus creative writing. This morning I picked on Thomas Wolfe. You don't need to write 1,000 pages on Depression-era teenage angst. You just need one sentence, crystal clear sentence. You don't need to pull out your thesaurus. Oh, gee, I've used this adjective too many times now. Okay, so what, right? go with it. If it's a useful adjective, then it's not creative writing, it's technical writing. Well, I think I got the quote wrong this morning. What is the office quote? Why use many words when few words do? Or,
Oh, why? Hold up.
Why say lot?
The other day.
a few people got it, even though I misquoted it.
Why use many when few do trick?
Yeah, there you go. Why use many words when few do trick? So.
And like the last thing, like when you're another challenge of like working with samples when you write is that like, right, you can't copy exactly what the sample says because that's plagiarism. But what you can do is kind of, this is where reverse outlines are helpful, right? Because if you stick to identifying the purpose and then saying, okay, I need to accomplish this purpose that I identified, you will not plagiarize because you're going to like make rhetorical choices. And by rhetorical choices, I mean language choices, syntactical choices that are furthering a piece of writing toward your goal. Like you'll make those choices if you can identify the purpose. But what you can also do is if you like the during the blank, we blank, that's a thing that you could say like, okay, we're gonna write, I can start a sentence with during and then use the function afterwards. Like that's okay. But what you're not gonna do is just say, okay, in my approach section, I have 4 phases. Like that's, you don't wanna lift, because your project is different. It might not have 4 phases. It might have only 2. It might, look, maybe bullet points are not the thing you're gonna need in this section, right? But for this particular author, it was necessary. So the goal is not to just like rote copy every single element, right, that's in a sample. That's why I really like the reverse outlining phase, because if you can identify how the elements match the purpose, that's what's gonna tell you what's my purpose and what are the elements that are gonna serve me that I should then do in my document. But again, reverse outlining, I do this whenever I have to write a new thing. If I like need to write a proposal for how to get more funding for the Writing Center. And I'm like, what even do I say to the dean? I'm going to get funding proposals from other, maybe, also there's other like tutoring, they have Study Stop for engineering. Maybe I'll see how they fund theirs and read their funding proposal and say, what are they doing in paragraph 1? What are they doing in paragraph 2? Oh, they use figures and data. I should maybe use figures and data. Like that sort of, those are the sorts of like parallels you can draw between samples and.
Yeah, and the student samples are for completely different projects. So the stupidest error that we see every year is somebody just cutting and pasting that and changing a few names around, whereas they leave in the old requirements or the old mentions of old projects. That's plagiarism, right? And it doesn't even make sense to plagiarize that way. So take the student samples and use them correctly. Read through them, see what a good sample looks like, or this professional sample looks like, then put it away, right? Don't look at it when you're writing your own, right? You can go back to it and then say, okay, well, how did that work? Or maybe better yet, don't go back to it if you've done the reverse outline, right? And just use your reverse outline as what I need to do, and then put it down in your own words.
Sure, I can do it. Okay, one last thing. What about, so here's another page of a design document. Talk for a second with your partner about why you might include this, and what about this serves the purpose of a design document? And why is it easy to read or not? No, that's okay. We've been switching.
Like it tells you what the model is, but this will be the last thing I'll do. You're trying to put it out. Like a lot of the things are like that. Whereas if you try to like write all of that out, you would want to like, would be like, so the essence.
Okay, so how does this help you understand what's going on?
It's a quick way to show how everything works together.
Mm-hmm. Why was this the best method given what you know about your audience and your purpose here?
Some of them might not know like class structures and such, so having it all in like these tables with first parts that identify what it is, and then second parts of what the data actually is, like pregnant children, whatever have you. It helps organize it in a way, in a more universal way than just purely computer science.
Yeah.
This is an entity relation diagram. You'll be generating something like this, right? To misabuse that quote again, why use many words when no words do the trick? Right? No words are here. This is all just diagram. You can focus in on one part at a time. You can see the relationships between that stuff. I think I heard it out there that if you were to actually write this as prose, this would be what, 10 paragraphs, and you would have to read it and reread it and reread it many times to get these summarized relationships.
And you can also think about some of the same things we were talking about before about, okay, which sections of this do you actually need to show? Do you need to show everything that you can output, or can you just focus on one section to prove your point? So people don't like to read, so don't give them more just because you know it. Give them what they need to know to do the thing that they need to do with this document. It can be really easy because you know the thing and you understand how it works to spend a lot of time explaining how it works, and sometimes you need that. But sometimes you don't. You could just talk about the end goal or the end result.
I mean, a lot of times even in scientific papers, maybe a paper will be just about theory. For example, in my field, it might be about how, nitrogen cycles through the ecosystem or something. And it's not a linear process. And it's very hard sometimes in words to describe something that's not this step-by-step thing. It's very iterative and all this stuff. So in biology papers, there are almost, like especially in ecosystem ecology, there are almost always these kind of like connection diagrams that summarize what really in words it would be a lot more difficult to convey. All right. So I have to go to another meeting, but Charlotte is going to tell you about the Writing Center and what it is we do and how you can come and bring drafts of your code or bring drafts of your design document to have another set of eyes kind of look at them and give you feedback.
Yeah.
Thank you.
Okay, so like we said at the beginning of this presentation, we're from the UNL Writing Center. Our main location is over in Andrews Hall. So has anybody been to the Writing Center before? A couple people, a few people. Okay, good job. Way to take initiative. So basically what the Writing Center does is we offer one-to-one consultations or appointments with undergrad and grad writing consultants. So we work with writing in any discipline. It doesn't have to be for school. So you can bring in like personal statements, cover letters, stuff like that, job applications, but you can also bring in assignments for classes. We also work with a range of writers. So I work with freshmen a lot, but I also have worked with like faculty on stuff. So it's really for anybody at any stage of the writing process, anytime you need help. I usually tell people, and this may be true of your writing or of your code, well, it depends. I guess I used to send everything I wrote in college to my mom, and maybe you too are sending your code to your mom. And your mom has other things to do besides looking at your stuff, and depending on who your mom is, she may or may not be able to help you. So come to the Writing Center instead of like bugging your mom or your partner or your roommate or whatever, because we're there to help you, right? And we can also help you at any stage of the process. So whether it's you just got an assignment and you're kind of having an anxiety attack about it and you just want to like make a plan for what you're going to do and get some brainstorming down, or if you're mostly done with something and you just want to run it by somebody else and make sure that it makes sense to another human. So we can work anything that's related to writing, including writing code. Our consultants are from a range of backgrounds, so we're not just English students, just like we work on more than papers for the English department. So we have consultants from all across campus and graduate students from all across campus as well. Okay.
Go ahead and drag it over. Yeah, drag it over there.
Oh, I see. Okay. So if you want to come to the Writing Center and make an appointment, I'm going to pass out some bookmarks that have all of our information on them. You can also just Google, thank you. You can also just Google UNL Writing Center. But the web address is unl.mywconline, mywritingcenteronline.com. And what you're going to need to do first, if you have never been to the Writing Center, is make an account. It's really simple. It takes a couple of minutes. It just asks you for some information so we can sort of track who's coming in. So you are going to make an account, and then you are going to log in. And this is the schedule. So blue blocks are places where you can't make an appointment, but the white ones are places where we're free. So if we scroll down and look at tomorrow, there's quite a few openings. So our appointments are 25 minutes or 50 minutes. Totally depends on what works in your schedule. And you can make an appointment ahead of time or you can walk in, but we do recommend that you make an appointment so that you're sure to find some time with somebody. So let's say I want to work with Caitlin tomorrow at 9 a.m. I just click on that spot. It'll ask you for some information about what type of project you're working on, just so the consultant you work with can glance at that ahead of time and take a look and sort of prepare. And you can also let us know if there's other stuff you want us to keep in mind there. So as I said, our main location is over in Andrews Hall. So all these hours are on the bookmarks and on the website, but we are open in Andrews Hall from 9 a.m. to 5 p.m. Monday through Thursday, and then 9 to noon on Fridays. So that's our main location. That's where we have the most people and the most regular hours. We also have evening hours Monday through Thursday from 5 to 7 in the Adele Learning Commons over by the Dunkin' Donuts. And then we have a bunch of satellite locations too, and those hours kind of rotate. So we have hours in the Gone Multicultural Center, the East Campus Union, and also might be notable for you guys, Nebraska Hall. So if you're over in engineering, we have a satellite location there too. This just means like the hours are a little bit less regular. It might be like 2 days a week instead of 4 days a week or something. So we already talked about how to make an appointment, what to bring when you come. So as you're preparing for your appointment, you might want to think about, okay, what questions do I have? What kind of prep can I do to make sure that I get the most out of this session possible? Definitely bring your rubric. Definitely bring any stuff that you've done on the assignment so far. If you've gotten feedback from an instructor or a TA before, it's great if you can bring that along too, so we get a sense of what the grading style is like, stuff like that. So bring everything you have and think a little bit ahead of time about what you want to focus on. The way that consultations work is it's basically just like a conversation between you and the consultant. They try to sort of guide you or give advice here and like as you go, but mostly like it's shaped by what you want to talk about. They're not a teacher who will tell you the right way to do something. It's more like you kind of talk through it together, the same as you do if you're sitting down with a friend being like, I can't figure out how to word this email. Does this sound okay? What do you think about this? Or what do you know about emails of this nature or something? So it's really like a conversation where you work together. The other thing I want to point out is sometimes people think that the Writing Center is a remedial service, like you go there, you get sent there as a punishment because you suck at writing and other things too, like, and it's like a bad place for bad people and bad writers. It's definitely not. It's like I said, we work with people at all stages of the writing process and all ranges from freshmen all the way through like tenure track faculty. So it's definitely, it's just a place if you need another reader and somebody to talk things out with. It's also really great to make a Writing Center appointment when you cannot get yourself to stop watching TV long enough to work on your homework. Because in the Writing Center, like it would be rude for you to be on your phone or watching Netflix while you're talking to somebody. So I have scheduled Writing Center appointments before because I could not get myself to stop procrastinating on something. And then either it was like a deadline, like, okay, I have to have a draft because I have my appointment tomorrow, or it was a time where I sat down and I was like, I haven't worked on this yet. Can you just sit here and like watch me like a hawk and make sure that I actually do this? So it can be useful in a variety of ways. You don't need to have like a complete thing. It can be like a very early stages brainstorming process. It can also give you brownie points with some of your instructors. If you come and you ask us to let your instructor know you came, that might help. I don't know. It doesn't hurt. It's a good rhetorical move.
I didn't catch if you mentioned it all, but they'll also do CV, resume, cover letters. So be thinking about that, because next week you do have your every semester STEM career fair. If you didn't go in the fall, make sure that you are going this semester. Go every semester. Go to the Writing Center, get your resume checked out, and they can tell you how to reformat it, maybe cut it down, make it look a little bit better. Then take 50 copies over there. Again, even if you're not looking for an internship right now, you will eventually be looking for one eventually. So, getting your resumes into the hands of employers now will mean that 2 years from now, you don't have to go out and job search. Instead, they'll be recruiting you instead. I was there last year. How many people did go in the fall? All right, good. Did you notice something? About half of them were all construction companies. So you might think, I'm never going to be in construction, right? But then did you look at what the job postings were in all these construction companies were? Computer science, software development, right? So it doesn't matter what kind of company you go to. So don't even just limit yourself to the STEM career fair. Go to the other section as well, because I'm sure that you'll find that a lot of them are hiring whatever they do, but then also they're hiring computer scientists, because they do have IT needs, they have programming needs, they have software development needs. Right? Everything is software now. You can't get away from it.
We can also help you if the idea of like going to a career fair or like talking to other people about yourself and your work kind of makes you anxious, makes you want to puke. You can also make a Writing Center appointment to get somebody to sit down with you and like work out what you are going to say to these people and like what are some good conversation starters for networking. Like if you want to talk to somebody about stuff like that too, this is a form of composition and writing as well. So we're certainly happy to work on like stuff like that. That's just planning what I'm going to say and how I'm going to say it. Just a slide here to highlight the engineering satellite, if this is more convenient for you. So we are there Monday, Tuesday, and Thursday nights, 7:30 to 9 p.m., as well as Tuesdays, 12:30 to 2:30 p.m. And you can make appointments here, or you can just walk in. Again, we love it when you make appointments, because then you're sure to actually find time, and it's a little bit more motivating for you. But if you are over there and just need some help on one of these nights, you can jump over there and see. So all of these hours are on our website and also on that WC Online where you can see the schedule. Does anyone have any questions about the Writing Center or about anything we've covered in this presentation? Okay, cool.
Well, thank you, Writing Center, for coming, and good luck on your please, and good luck on your design documents.